Oh, I'm so silly. Okay, today I want to talk about motherboards. And specifically, I want to talk about ITX styles, but I'm also going to talk about some other motherboards that are out there because um, there's more than just one style. I mean, you do kind of have to be aware of what all of those styles are, uh, and like the importance behind them because they're important. Motherboards are one of the most important aspects of our computer. If we consider our CPU to be the brain and or the heart, depending on who you talk to, uh, and you build your build around what this is capable of doing. Our motherboard is kind of our nervous system and our blood vessels, and it's what allows all that information to flow. So you have to care about it. I mean, because if a motherboard isn't capable of handling what this is capable of handling, then it's just not going to work. I mean, you're going to have bottlenecks. Uh, so it's really important to be able to take that into consideration. So this is an Intel Asus H170 Plus D3. This is a little bit older style gaming motherboard. This is very much your basic motherboard. Uh, this is probably something that you're going to commonly find uh, on older computers, and it's been around for a little bit. And as we sit here, and we can take a look at this, at what it has capabilities of it, but it did have M.2 support, but it has PCI 3.0, 4 times interfaces, so it's not going to do a lot. But if you notice, it has DDR3 memory capability, so that kind of drops its capability down. Meaning you're not going to get as much throughput as if you were to have DDR4. Um, you can kind of say, take a look at this picture. It still has VGA, and DVI-D still is common. HDMI, very common, but it has no uh, display port capabilities on it. It is running USB 3.0, but not 3.1. So while capable, is probably not your best option out there. Um, but it is meant to be kind of simple. This is the type of motherboard. This is the type of motherboard that for a lot of people might be their first DIY project, their very first one that they're going to do, because it's simple, uh, it's cheap, and yeah, so it's a pretty common little motherboard. Your first time building a PC, if you don't want to spend more than a couple $100 on it, this very likely could be what you purchase. Um, yeah, it's kind of a nice little looking board there. Now, if we go up a level here, and there's two of these boards that I currently have. I have an ITX version of it, which we'll get to here in a second, but I'm going to bring up an ATX version of a. Oh, there we go. An Aurora's M70 Master. Um, this is not the highest end capabilities out there for Aurora's motherboards, but it is definitely on the higher end. These boards are significantly more expensive, and put that angle for everyone to see. And it's a good looking board. Get a good view of it facing. Yeah, look at that bad boy. So what this board is missing, which I'm going to do today, is we attach the RAM to it. So this is an AMD board. This is made by a company called Gigabit. Uh, Gigabit is kind of a common. It's one of the handful of fairly decent motherboards that are out there. Uh, I have several AMD boards. Sorry, not yeah, several AMD boards, and Aurora's does what it's meant to do. It's pretty straightforward. They're nice looking boards. Uh, Take a look at the way the heat sink and the RAM all look upon each other. If you notice right there, this actually has light up LCDs on it, uh, so that it'll tell you its error code. So this board is running PCI 4.0. Those capabilities are a lot higher than an Intel board that we just took a look at. If we go back to our browser, and we take a look at where did my buttons go? Okay, that's awkward. All right, there we go. So this is the ITX version of it, the one that I currently have that we're going to build my SFF off of. But it has a lot of the same components. So let me bring it up 570. There was master. So we can look at what its capabilities of. Okay. So this is that board that I just had in my hands. Let's go down to the specifications. There. 4 times DDR4 DIMM slots. This board is capable of handling up to 128 gigs of memory on it, 32 gigs per slot. If we jump back to this guy, look at its specifications. 4 times DIMM, max 64 gigs. So between that older DDR3 board and this newer AMD board, we can double the amount of RAM capability on it. So it has better capabilities. And our other things we have to take care of is our PCI slots. If we have a 3rd-gen Ryzen processor on one of these boards, we're actually going to get PCIe 4.0. And 4.0 runs significantly better than 3.0. So we're getting faster speeds. And then we take into consideration our M2 that we can put onto this board. And with a CPU that is capable of running PCI 4.0, with a motherboard that's capable of running PCI 4.0, in RAM, and we're talking about a whole system, a whole board that can run significantly quicker. But if I were to put a Ryzen processor into an older board that doesn't have 4.0, it will still manage at 3.0, but it won't run as fast. It won't be quite as capable. But if I put this chip into something even older than that, it might not even support it, might not even run. Its capabilities would just be lost. So something that's to be considered. So this is a full ATX size motherboard. Let's go take a look at this picture. Now our ATX sizes is our common desktop size. So if you see a tower computer, this is what you're going to be taking a look at. And this is definitely very much a gaming board. It's got light up features onto it. Asus does a really big job of making their coolers, showing off all their coolers and their heat sinks. Like, you look at that heat sink is pretty big, but if you look at those fins, see if I can get it. So if you look at the fins in the back of the board, I mean, you just have this plate that's going over top of them. Uh, and you're just trying to pull that heat off as much as you can. But these type of boards, they have these other covers on them so that you can hide the heat sinks. You want to kind of make them more pleasing to look at. Yeah, you really want them to try to be to look appealing. And then you also have covers over top of our south bridge. And this is where the chipset for the X570 is sitting, is underneath this little guy right here. Now we would go back and take a look at that Intel board. So I said there's an H170 Plus. That right there is where the south bridge is sitting at. This little tiny heat sink sitting on top of it. Now you can kind of take a look at that from a side view. There's not much there. That heatsink isn't going to be, shouldn't be pulling that much heat off of it, because it shouldn't be generating that much heat. We go back and take a look at that Aurora's board. We have a little bit bigger heatsink, but we also have a lot more stuff that it is handling. Is a south bridge something that we have to worry about overheating? Nah. Do we have to worry about this whole side potentially overheating? Oh yes. That's a concern. You don't want any of that to overheat, because if that's overheating, you're probably taking down your entire computer. Let's look at our I/O panel on this ATX board. There we go. So this board has the capability to flash its BIOS by simply clicking a button. So we have AMD's little Q Flash Plus and Clear CMOS. You can probably hear it. They have little audible clicks, and with those we can flash or change over to a different BIOS. A board like this has the capability of running two BIOSes at the same time, because this board is capable of what we consider overclocking. So when we talk about those gigahertz and hertz frequencies and stuff like that, it's all running off time. A motherboard is what's controlling that time. Take a look. We have a battery on there. That little battery is keeping time on that board, and time is one of the most important things about it. So if we start messing with frequencies and start changing things up just a little tiny bit, we can start sending data at more data over a shorter period of time, which is where you get that overclocking capability coming from. Other things that are on here for the I/O, if you notice, this has dual NIC cards. It has both a 2.5 gig and a 5 gig NIC card on it, which means that this board here can connect the two separate networks at the same time. And you're probably wondering, why would you ever want to do that? Well, one, so you can connect to the internet or some type of object that's going to connect to the internet. Then also at the same time, you can connect to a LAN network that is around your computer. And you can kind of think of this kind of as a little bit of a safety measure sometimes, especially if we want to segregate. If you want to segregate your traffic to internal traffic and only talking to internal objects, or if you're wanting to kind of have like maybe two internet connections coming in or two different networks coming into your computer. Also, a good way that you can be able to do this is if you have a secondary computer that you're using for streaming, and with this type of board, I can directly connect through Ethernet and send that data through an Ethernet cable then versus an HDMI or a display port. Other interesting things, if you look at this board, you'll notice there is no display connections on it. So you're not going to connect an HDMI to it. There's no HDMI signal. There's only USB. We have 2 Ethernets, 1, 2, 3, 4, 5, 6, 7, 8, 9 USB, and 1 USB-C, which is coming kind of standard now for more modern motherboards. You want that USB-C. And then we have audio. And really interesting, we have optical audio, which is also becoming a very common thing on our modern motherboards. Now, we jump back over to this older board. Look at that. We have PS2, we have VGA, we have HDMI on there, and we only have 4 ports. I'm sorry, 6 ports, only 4 of them are 3.0, but we have those old pink, green, and blue audio connectors. So this is standard audio. This isn't even high definition audio coming out of this board. So yes, standard ATX size board, standard desktop one. Other interesting things on a board like this, we have dual CPU power, meaning that this, while it will run off one, which is always going to be the closest one to it, if you connect both and you're doing overclocking, you are now giving additional power to the board to be able to handle the overclocking. What this board does, oh yes it does. That little port right there is what allows you to have a case with a USB-C connection. Without that little port right there, if you have a USB-C, say you have a case with a USB-C connection on it, without that port there, you would not be able to use it. Or you wouldn't be able to use it as well. You can get an adapter and send it down to one of these guys, but these are just standard USB 3 connections, which is how you normally do any of your case motherboard, case USB connections, is by these guys here. And then if you look at the bottom of that, you can see the rest of the possible connections that we can do to the board. So that's an ATX style board. Put this one away, and then we'll start talking about the ITX, which is the one I really want to talk about because that's the one that I am building my current SFF build on. And one of the most important things about this build is that it needs to be small. And I need it to be small. The whole premise of it is that it's only going to take up small rectangle worth of space. So if you're ever doing work on a motherboard, you have 2 ways that you can go about doing things. You can use an anti-static mat, or you can go ahead and use your cardboard box that the box came out of. And I strongly recommend just go ahead and using that cardboard box as an anti-static mat. So whenever I place this guy back down, so here this board is nice and small. So this is an ITX size board. It is a perfect square. About there. Okay. So tiny, small, lightweight. This board, you'll notice I can only do 2 sticks of memory on it. And there's our CPU spot. And I only have 1 PCIe port. And that port is when you make for the graphic card. Let's take a look at the side view of this one. Now, comparatively, compared to the other board, you're going to notice I have DisplayPort, I have HDMI. So this little guy here doesn't have quite as much capability as what that ATX board. It has less slots for additional items. So I can't put like a graphics card and another memory one. I can't just keep on adding things to it. It doesn't work that way. Uh, but I don't need it to. Uh, if you're going to overclock, you don't need a second PSU. You just need a powerful enough PSU. And this is a matter of just calculating all your power and making sure that your draw isn't going to be more than what you're capable than what your power supply is capable of doing. This little guy here only can draw about 98 watts total. So it's not going to do too much. But I can overclock on this one too. But the big difference is, let's see if it focuses in on it. I only have one slot for CPU power. So I'm not going to get as much overclocking from this type of board than I would an ATX capable. It's just not what the board's meant for. So ITX boards are meant for smaller builds, things that you kind of want to put out of the way, or you want to hide behind other objects. So small, thin cases is where you're normally going to see an ITX board at. You wouldn't normally see an ITX build in a massive case. You'll normally see an ITX build in a small case. Now, Wienerberg. So these are my HyperX Furies that I'm going to go ahead and install on this board here. So we can go ahead and take a look at what it looks like with the RAM installed into it. Now these RAMs here are very low profile. If we take a look, I'm going to kind of click those here. So you'll be able to hear the click that goes with it. Nice and low profile. They don't take up much space. And when we looked at RAM, the big DDR4s, they were significantly taller than this set. This is smaller. It's meant to be smaller. And with this one, I'm also going to go ahead and put the CPU in since I have it here. I want to show something here really quickly. One of the most aggravating things about AMD motherboards, it's this silly little clasp. This is the only thing that's really keeping down your CPU, which is a little bit simpler to use in Intel boards, but quite honestly, when you're properly thermal paste and the thermal paste's been sitting on for your CPU for a while, it's just going to pull the CPU off of this. We're going to go ahead and put this in place here. Then I'm going to go ahead and show everybody. So I want you to notice the way, there we go, come in the view. So I want you to notice the way that the Ryzen logo is facing. If you look on that bottom little triangle, see that little tiny triangle right there? And then if I were to rotate this, let's rotate this like this would actually be sitting in a computer, like I had that other board. If you notice the direction of where that triangle is facing, all boards are going to have the same layout. So if your I/O port is over here, that little triangle is going to be facing the same direction. and the chip can only fit in there in that direction. Uh, if you rotated that chip around and you try to do it with the Ryzen facing a different angle or direction, and you force that chip into place, you are going to bend pins. And you're basically going to ruin that motherboard very, very quickly. Uh, yeah. So let's go back and take a quick look at the manufacturer stuff on this board. So this is the X570 Aurora Pro Wi-Fi. Now you're probably wondering, why did I stick with another Aurora board? One is price range. I was again trying to keep the prices down on this board to items that most people could purchase. Uh, so meaning that this is an affordable board. This is an affordable build. Other reasons why, because one has the 4.0, the chipset can handle the 4.0, the graphics card that's going to go in here and eventually doesn't really need it, but it will have the capability of handling it, and the storage will be able to handle the 4.0. It also means that it's upgradable. So when Ryzen 5s come out later in November, and they eventually go on sale sometime next year, I'll be able to swap out this 3400G to a Ryzen 5000 series and increase its capabilities without having to replace the motherboard. This motherboard, like most of the gaming brands, are RGB. When this all gets installed, we'll go ahead and turn those off. We don't actually need RGB for this build, and again, you're not ever going to see the internals of it. The externals are going to be a little bit more important. Let's go look at our specifications. Okay. So if the chip has an integrated graphics processor, we have the capability of having DisplayPort and 2 times HDMI, which this chip does. This chip is coming with an integrated graphics processor with it. But it's sharing memory. It can support up to 3 displays, and the operating system is going to share, operating system and the graphics card is going to share the same memory, meaning there's not dedicated memory for the graphics. Also has high definition audio. Both boards that we looked at has the capability of what we call Wi-Fi 6. This board is not going to be used with the Wi-Fi 6. Those won't even be connected because it'll be physically connected to the network. It's only going to come with one. Where's my PCIe? My PCIe. Where are you, PCIe? But it's only going to come with one PCIe slot onto it, which means I'm only going to attach one additional item to it, but that it's going to run at the 4.0 chain. I want to show you one other thing that's really interesting about this board. And you might have noticed if you were looking. I'm going to show it to you again. Can anyone figure out where the memory is installed? So, with this type of board, you install the memory on the back. So when we talk about storage next, that's where it's going to install. It's going to install on the back of the motherboard. They do that on ITX boards, not all ITX boards, to allow for more items to be on the board. It allows us to utilize more features of the board that add in more capabilities by just rotating it and putting it on the back of the board. And this is not uncommon. You're actually seeing some big boards, your ITX, not sorry, your ATX boards now coming with that capability, where they're starting to put additional uh, M2 slots on the back of the board. It's common. So by taking a look at this square, this 10 by 10, or sorry, 8 by 8, 8 by 8. I don't know why I keep on saying 10 by 10 today. Uh, this 8 by 8 board, you can kind of tell the size of this whole case. If this is going to sit on one side panel of it and be facing down, which is going to, our whole board, our whole computer is only going to be this big when looking from the top. And it's only going to be about this wide. So that should be able to, you should be able to think about that and take and see the size that we're creating with this. So motherboards, so kind of round out today's little thing about motherboards, is they come in all shapes and sizes. Uh, you can get them as small as what you put in your cell phone. Your cell phone has a motherboard into it, and your RAM and your CPU and all that will be connected to it. Uh, and then you get big motherboards, or ATX sizes, uh, which are full desktop versions of motherboards. And realistically, that brand new cell phone, the latest Apple version, that latest one, as time progresses and you're able to put more features into that small board, this old board might have less capabilities than what that new cell phone does. Again, this is only a couple generations behind, but it is running on DDR3. Your brand new phone is going to run on DDR4. Uh, so yeah, uh, your cell phone is a fully functional computer, and it has a motherboard into it. It has some type of chipped memory that's being directly attached to that motherboard. That has some type of north bridge south bridge situation. It might be a combined. Like when we look at this ITX again, our our chipset is sitting underneath there, um, which is common for that size of board. So the smaller you go, you just start combining those features. So everything has a motherboard. Again, if we consider the CPU to be the brain, the motherboard really is kind of like the blood vessels and the nervous systems. Uh, and properly, if you don't get the features that you want with your motherboard, or you go for a board that's not compatible with your CPU, one, it might not even work. More than likely, it won't work. And two, if it does, you're bottlenecking it. Uh, so you have to stay within those considerations. That is actually it for tonight. All I wanted to do was talk about motherboards, and motherboards don't take that long to talk about. All right, everybody, have a good night. Bye.